All right, this is Mr. Gilman. Today we're going to talk about similar triangles and how to know if they're similar or not. Obviously, we've talked about similar triangles. We know that in similar polygons, all the angles are congruent from one to the next. Okay, it doesn't mean that their side lengths are congruent, but it does mean their angles are all congruent. So we're going to talk about like side, 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 side angle, side, angle, angle similarities today. And the way I remember the angle, angle similarity is I know there's 180 degrees in a triangle, especially, and if I have this much of the 180 used up and it's the same amount as this little triangle here, that means there's the same amount left for the third angle there. Okay, so I believe we call that the third angles postulate. So anyway, if I know that all the angles are congruent, I really only need to know that two of them are, because through necessity, the third angle would have to be congruent on both of them as well. So we just call it the angle-angle similarity because you really only need two angles because the third one is understood to be the same. When I think about this one, I think about like when you grab like a clip art. Let's see if I can do that here. If you grab like a clip art of a triangle, and as I make it bigger or smaller, you can see that the angles aren't changing at all. If I move it straight up and down, the sides are maybe just stretching. But if I make two triangles the same here, if I make them perfectly the same, they'll be the exact same angles with different side lengths. All right. So as long as I know that two of the angles are the same, that guarantees the third one to be the same as well. I think you get the idea. So that's called the angle-angle similarity. So when we look at this to determine whether or not they're actually similar or not, we just need to make sure that two of the angles are similar. So it looks like we have a 48 degree and a 57 degree angle. So right now totaling we have 105 degrees, and that leaves 75 degrees for this final angle here. And it looks to me like we have two angles that are congruent, the 75 and the 57. That means that it's guaranteed that this last angle must be the same in both of them. So I would say through the angle-angle similarity, that these would be similar triangles, not congruent, similar. All right, so if I wanted to write the actual similarity statement as it says in the directions, I'm glad I noticed that, that's what we need to do. So I would say that triangle, and I'm going to start with the smallest angle first, J, 48 degrees, LK is similar to triangle, look at the smallest one again, Q, second smallest, M, P. There's my similarity statement. I know they're similar because of angle, angle. I do a little work to make sure that there was two angles that they shared the same. But now that I do know that all three angles are congruent, in fact I only need two of them, I can say angle, angle similarity says that these two triangles are congruent, and here's my similarity statement. Okay. Once again, I'm gonna have to do a little work here on this guy right here. So what I'm gonna do is I'm just gonna extend these lines so you can see kind of the visual that I'm looking at here. If these are both parallel, that tells me that this angle and this angle are actually congruent because they're alternate interior angles. So let's just go ahead and put one dash on those. I also know that these angles are vertical angles, so they must be congruent. So that leaves the same amount of angle to be left in the third one. That's kind of going overboard because once I know that I have two angles the same in both triangles, I can write a congruency statement. So once again, this is the angle-angle similarity. As you can see, it's important to remember these things that we've learned with parallel lines so you can find the congruent angles. And once again, I'm going to start, let's just start with S on both of them. I think that's going to be the easiest way. And then I'll go from the 2, then I'll go to the 1. So if I'm going from, this is triangle 1, this triangle 2, I'll do R next, and it has one dash, so I'm going to go to that W over here, and then last but not least the 3 dash, so I'm going to say X and T. I'm going to say those are similar. All right, so the angle-angle similarity. So you might have to remember some of these relationships here and that type of thing. We can't really tell the scale factor in this case because we don't have any side lengths, but we do know that they are similar. Let's look at side, side, side similarity. And that basically says that if the proportions are equal from each side length to the next, then they are for sure proportional. So if I just put some numbers in here just as a generalization, let's just say this guy was 6 and this guy was 3, We could do 8 and 4, and we can do, I think our hypotenuse should probably be the longest, so let's do 10 and 5. I'm just going to compare each of the side lengths proportional to see if they're proportional or not. I'm going to compare the green ones together, 6 to 3. It should equal 5 to 10. Oops, always go in the same direction from the first one, from left to right is what I try to do, always. So then 10 to 5, and then 8 to 4. And so if you accidentally flipped the numbers here, they're not going to be proportional, obviously. So make sure you always go with the comparisons. All the comparisons of the big triangle are on top. All the comparisons of the small triangle are on the bottom. In this case, if I reduce all the fractions, they should be the same. If they're not the same, then they're not proportional. 2, 2, 2. So in this case, with these numbers that I made up, these will be proportional because each side is the same ratio, has the same scale factor from one side to the next. Okay, so that guarantees that they're proportional as well. If this had been like a 6 here, then we would have had a problem. It wouldn't be proportional anymore because 10 divided by 6 would not be the same as the other two sides ratios. All right, so side angle side similarity. The same idea as side angle side congruence with triangles, except this time it's similarity. If we know that instead of saying that RS is equal to XY, if we say that the proportion from RS and XY is the same as the proportion from ST to YZ, and the included angle is the same, then we'll know through side angle side similarity that the triangles must also be similar. Okay, so it's kind of one of those deals where we're going to practice and we're going to do a couple more each time. But the rules are the same, except for now instead of congruence, we're talking about similarity. So let's just pretend I had a 2 and a 4 and a 3 and a 6. And it's just a hypothetical. And I had this included angle in here that I was guaranteed is exactly the same. All right, I would first have to check both sides to make sure those had the same ratio. So if same ratio. Is 2/4 equal to 3/6? Well, I could say, okay, well that's 1/2 equals 1/2. That's true. So those two sides are definitely proportional. I just need to make sure that the included angle, meaning the angle in between the two sides I was comparing, is the same as well. In this case it is, so I would know through side angle side similarity that those triangles are similar. I don't know that they're congruent, but I do know they're similar. All right. So once again, we have another practice here. It says determine whether the triangles are similar. If so, write a similarity statement and explain your reasoning. So it looks to me like this guy kind of could be rotated around this way. So that's what I'm going to do. That's what I'm going to compare those ratios to see if they're equal. I do know that I see right here right away that these angles are equal, are congruent. So if I want to try to approach this through the side angle side, that would be good. If I can prove that the ratio of this guy to this guy and this guy to this guy are the same. So that's what I'm going to try to attempt to do. I'm going to compare 5 to 12.5. And I'm going to compare that to 8 over 20. Okay, I'm going to compare the 5 over 12.5 if I had rotated this. And I'm going to compare the 8 to the 20. And since I already have the included angle, I know that's out of the way because that's in between the 5 and the 8 and the 12.5 and the 20. So now it's just a matter of seeing if this ratio, this proportion, is a true statement. I don't really like to use decimals at all. And so when I see decimals and fractions, I just multiply by 10, 100, 1,000, whatever it takes to move this decimal point over one. I'm going to take this times 10 over 10 and just say this is really 50 over 125. I'm going to compare it to 8 over 20. I'm just going to reduce. Another way to tell if the proportion is a true proportion without doing a whole bunch of fraction work is to cross multiply. If 100 equals 12.5 times 8, then I know it's a true statement. All right, and so in this case, I think it will be. So you can approach it either way. I can just cross multiply and make sure that those cross products are equal, or you can reduce the fractions and make sure they're equal as well. I know 5 goes into 50, 10 times, and into 125, 25 times. I know 8/20 reduces to, if I divide both by 4, 2/5, and once again I can reduce to 2/5 over here as well. So 2/5 equals 2/5. That would be fine. As you can see, their cross products would be equal as well. So you can do it however you want, but as long as I know that those two sides have the same ratio, same scale factor, and the included angle, then I know that for sure they are similar. So I could say, yes, they're similar through side angle side similarity. And my congruence statement could go like this. Let's just make sure we have, so we're going to say, okay, let's start with the angle that we know first. The R, triangle with the R in the front. Okay, I'm going to go to R to Q. And so I'm going R to T in this one. And I'm going to go with the last one that's left, P and S. And say those are similar. All right, so once you can kind of use your proportion statement to figure out what the congruent or the similarity statement is. And once you have two, there's only one variable remaining. So one side remaining. So determine whether the triangles are similar. So write a similarity statement, explain your reasoning. Okay, it's hard to make out the two triangles here, but the triangles I'm talking about are triangle ACB and triangle AEF. Okay, those are my two triangles that I'm comparing. And so I need to know if their ratios are the same. What I do know through the reflexive property, and that's going to be important when we start doing proofs, is that they both share angle A. So if I can prove that the two sides next to that shared angle are proportional, then I can show that through side angle side similarity that the two triangles are similar. So if I look here, I have AE, if I'm comparing, is 8. I'm going to compare it to the whole distance AC. So let's make sure that we do this right. If I have 8 here and 4 here, this total side length is 12 to AC. I'm comparing 8 to 12 if I'm comparing the small one to the big one. So I should really have written this the other way around, so not to confuse anybody. And then we'll compare this hypotenuse side, 10, to the full length. Again, don't compare it to 5, compare it to the whole side length. So 10 plus 5 is 15. 15. And once again, you can find the cross product, 8 times 15, and that should equal 12 times 10 if they are proportional. Or you can just reduce the fractions, which I usually do. 2/3 equals 2/3. In this case, they are proportional. So once again, we do have a side angle side similarity. And since I already wrote down the two triangles that I'm comparing, I'm just going to write that as my similarity statement. Triangle AEF is similar to triangle ACB. All right, so that's it for today. We're going to throw in some of these things, these similarities, and they're going to be a lot like the congruence, but we're comparing ratios and scale factors to making sure they have the same scale factor instead of just making sure that they're actually congruent. So that's it for today.